Here's another example of a rational equation. It's an equation that contains fractions, and in particular, the denominators of the fractions contain the variable. We don't really know what kind of equation we have until we remove those fractions. And we always have to be careful that the solution we get doesn't make one of these denominators become 0. What value of x, if we plugged it in here, would make this denominator become 0? Wouldn't that be negative 3? We couldn't let x be negative 3 because negative 3 plus 3 would be 0. Or we couldn't let x be positive 2 because 2 minus 2 would be 0. So when we get our solution, we better check it to make sure that the solution we found wasn't negative 3 or 2. If it was, we'd have to throw it out and say the equation had no solution. Now, we want to remove those fractions, so we've got to find a multiplier. Well, to cancel this fraction's denominator, isn't it going to take a multiplier of x plus 3? And to cancel this fraction's denominator, isn't it going to take a multiplier of x minus 2? So I need to multiply this side of the equation by that pair of binomials, because I have to multiply everything there by the same quantity, so I'll have to multiply by both of those binomials in order to cancel out the fractions that are there. Well, will those binomials cancel out the denominator that's here? Well, they would if the factorization of this trinomial is those two binomials. Let's see if it is. Will this trinomial factor into the pair of binomials we have here? Well, let's just put them down and see if it works. That's what I'd like to have happen. Does the product under FOIL of these two binomials give me that trinomial? X times x would be x squared. Minus 2x plus 3x would be plus 1x. And plus 3 times minus 2 is minus 6 when we use our FOIL method to multiply. So sure enough, multiplying this side of the equation by that pair of binomials will also cancel that denominator. So I want to take these terms I want to take each of these terms on the left-hand side of the equation, multiply by those two binomials, and I want to take the right-hand term and multiply by those two binomials. And as I do that, I'm going to cancel out all the denominators of the fractions. Here, the x plus 3's cancel, leaving me 6 to be multiplied times the binomial x minus 2. Minus, here, the x minus 2's cancel, leaving me 5 to be multiplied times the binomial x plus 3. And here, the binomials cancel each other completely, just leaving us negative 20. And now we have created a linear equation in one variable that we can solve. Let's remove the parentheses. 6x minus 12 minus 5x minus 15 equals negative 20. Combine the like terms here. 6x minus 5x, that's x, minus 12 minus 15 minus 27. Add 27 to both sides, I have x equals 7. And my solution to this original equation is that x equals 7. Can we accept that solution? It's not negative 3, which would have caused a problem here. It's not positive 2, which is what would have caused a problem here. So I can accept that solution. Whether or not it's the actual solution, I wouldn't know until I plugged it in to see if it makes the left-hand expression's value the same as the right-hand. Then I would know for sure that I have the solution.